Have you ever wondered how your GPS just knows the fastest route even when there's traffic? Or how an enemy in a video game can hunt you down so perfectly? Well, welcome to CS Course Companion. The secret behind all of that is a super powerful AI technique we're going to break down today: search algorithms.
Now, really, think about it for a second. When you ask your map app for the quickest way to get somewhere, it's not just choosing from a few roads. It's sifting through an absolutely insane number of possibilities. We're talking millions, maybe even billions, to find that one perfect path. So, how on earth does it do that?
While the answer is this core AI concept called search. And in this explainer, we're going to unpack exactly what that means. We'll start with the simple, kind of slow brute force method, and then we'll reveal the secret ingredient that makes search so smart, something called heuristics, focusing on one of the most famous search algorithms ever, A*. At its core, AI search is all about having a problem-solving agent. You can just picture a little robot, right? And this robot has a goal, like, say, getting to a specific destination, and it needs to figure out the exact sequence of moves to get there. So when we say search in AI, this is what we mean. It's the process of methodically exploring all these different sequences of actions. It's not about random guessing at all. It's a very structured way to find a path from point A, your initial state, to point B, your goal state. Now, to really get this, we need a few key terms. First, a state. A state is just any possible configuration of the problem. So in a game of chess, every single possible layout of the pieces on the board is a unique state. The search space is all of those possible states combined, the entire universe of possibilities, which can be astronomically huge. And of course, the goal is that one specific state we're trying to get to, like the checkmate position.
All right, let's start with the most basic way to solve this. Imagine you're dropped into a maze and it's pitch black. What do? You'd probably just put a hand on one wall and just follow it, right? Well, that's pretty much the idea behind what we call uninformed or blind search. These kinds of strategies know the rules, they know what moves they're allowed to make, but they have absolutely zero extra information. They can't tell if heading left is any better than heading right. They just explore, one step at a time, completely blind to where the goal might be. And this quote just nails it. It's exactly like trying every single key on a massive keychain until one of them finally clicks. I mean, it'll work, eventually. If a solution exists, a blind search will find it. But if that keychain has millions of keys, yeah, you're going to be there for a very, very long time. It's thorough, but it is incredibly inefficient.
So how do we make our little robot smarter? Simple, we give it a clue. It's like turning on the lights in that maze, or giving it a compass. In the world of AI, this clue has a special name, a heuristic. And trust me, it is a total game changer. A heuristic is basically an educated guess. It's a special function that can look at a state and estimate how close it is to the goal. Now, it's not always 100% accurate, but it doesn't have to be. It just needs to provide a sense of direction, letting the AI focus on paths that feel like they're heading the right way. And this slide really puts it all into perspective. On one side, you have uninformed search. It's blind, it's brute force, it's just wandering. On the other, you have informed search. It's guided, it's smart, and it uses clues. And this is the big aha moment. That simple clue turns a nearly impossible task into something manageable. The leap in efficiency isn't just a little bit better, it's monumental. Okay, so this brings us to the big one, the most famous and widely used informed search algorithm out there, A*. And yep, you say it, A*. It is the perfect example of a smart, efficient search that uses a heuristic. The entire genius of A* can be boiled down to this one single elegant formula. F of n equals g of n plus h of n. This little equation is how the algorithm decides which path to check out next. It's all about finding the perfect balance between what it already knows for sure and its best guess about what's coming up. So let's break that down. G of n is the cost so far. This part is a hard fact. It's the exact price we've paid, whether that's distance or time or number of moves, to get from the start to where we are right now at state n. Then we have h of n. That's our heuristic, our educated guess of the cost from where we are now all the way to the finish line. So f of n is just the two added together, the known cost of the past plus the estimated cost of the future. Okay, let's see this in action with the classic 8 puzzle. So we're at the start and we can make 3 possible moves. To figure out which one is best, we use our formula. Let's look at that middle option. The cost so far, our g of n, is 1 because we've made just one move.
Our heuristic, h of n, which in this case might just be counting how many tiles are in the wrong spot, is 3. So you add them up, 1 plus 3 gives us a total estimated score, or f of n, of 4. A* does this for every single possible next step.
And here is the secret sauce. A* keeps a to-do list of all the places it could explore, and we call this the open list. Then it always, and this is the important part, it always chooses to explore the path that has the lowest f of n score. So in our last example, it would pick the path that scored a 4 instead of the ones that scored a 6. By always working on the most promising path first, it saves an incredible amount of time.
So this is a pretty cool computer science concept, but where do you actually see it? Is this just theory? Nope. The answer is it's everywhere. These algorithms are the quiet, invisible engines running behind a ton of the technology you use every single day.
I mean, the most obvious one is route planning, right? When your GPS or Google Maps finds that perfect route home, dodging all the traffic. Yeah, that's A*, or an algorithm just like it. In video games, when that bad guy navigates a super complex level to find you, that's pathfinding, using a search algorithm. It's even used in really abstract stuff, like helping to prove mathematical theorems or searching for the right models in machine learning. So, if you take one thing away from all this, it should be this. The journey from a dumb, blind, brute force search to a truly intelligent, guided one is all thanks to heuristics. That educated guess is the key that unlocks the ability for an AI to solve incredibly complex problems efficiently.
But that does leave us with one last really fascinating question to think about. The whole power of A* comes from its heuristic, right? From its educated guess. So what happens when that guess is bad? What if it's just plain wrong and misleading? Can a bad heuristic actually send a smart search algorithm way off course down a totally useless path?
Thanks for joining us on this deep dive into AI search. If this helped clear things up and you want more CS topics explained just like this, make sure you hit subscribe and ring that notification bell. And definitely let us know in the comments, what do you think happens when a heuristic is wrong? We'd love to hear your ideas. We'll see you in the next one.